inequalities take two forms. They are literally just regular old inequalities, but we squish two of them together. We are going to join two different inequalities using either the word and or the word or. So let's start by talking about and inequalities. And inequalities can take two different written forms. The most basic one that we're going to see is when we literally just write two regular inequalities and put in the word and in between them. So for example, I could say x is greater than -1 and x is less than 2. That's two inequalities that we've seen before, just with an and in the middle. With and inequalities, this is something we can do only with and inequalities. We can also squish this together into one line, one compound inequality that looks like -1 is less than x is less than 2. So two correct options for how we write these inequalities. When we graph these inequalities, we only really need 3 points, but I'm going to show you this with a couple more points just so we can see what's really going on here. Let's do -2, -1, 0, 1, 2, 3. If I'm writing an and inequality, this is saying x is greater than -1, which means I get an open circle at -1, and I'm going to point towards the middle to all the numbers greater than -1. And x is less than 2. This is telling me both things need to be true. So x is less than 2, but greater than -1. Both of those things must be true at the same time. Sometimes people just shade in the middle like this. That's also fine. And inequalities always face towards each other. So they're always going to meet in the middle like that. Essentially what I'm saying here, in a lot of words, is that an and compound inequality means x is between two numbers. So in this case, it's between -1 and 2. Any questions on that? The second kind is an or compound inequality. We write or compound inequalities like so. We would say x is less than -1 or x is greater than 2. Both of these things cannot be true at the same time. You are either one or the other, or maybe you're neither, but you are never both less than -1 and greater than 2. It's not possible. What you should notice here is that we cannot use this form that we did with the and. We cannot squish it together. So that's not a form that we can use for any or inequalities, but we can just write them next to each other like so. The graph of an or inequality. Let's go ahead and graph this with the same numbers that I used before. X is less than -1, open circle. I'm pointing to the left to all the values less than -1, or x is greater than 2. So pointing to the right to all the values greater than 2. Or compound inequalities will always face away from each other. So the arrows will never meet. You cannot be both less than -1 and greater than 2. One or the other, or maybe you're in the middle and you're neither. Any questions on that? So what this means is either x is less than -1 or x is greater than 2. Any questions on that? Can we read that? Sorry, I'll make it a little smaller. Okay, so let's now focus on writing these compound inequalities and graphing them. So in example 1a, it says the recipe calls for baking the cookies for 13 to 18 minutes. Should we cook the cookies less than 13 minutes?
No.
Should we cook the cookies for more than 18 minutes?
No.
Probably not, right? The sweet spot is somewhere in between 13 and 18 minutes. So that means if I'm looking at something between, that's going to be an and compound inequality. I mean, you could do 14 minutes if you really want to. So one option for writing a compound inequality with and is two separate inequalities with the word and in between them. Let's call x the number of minutes that we are baking these cookies for. Then x has to be greater than or equal to 13, and x has to be less than or equal to 18. We could also squish them together. This is also a valid way to write and compound inequalities. We could say x is between 13 and 18. Questions about that? So when I write this on a number line now, I'm going to take my two numbers, 13 and 18. We know how a number line works, right? The smaller number goes on the left. So I'm going to put the smaller number, 13 here, the bigger number, 18 on the right, and then I could just pick a number in the middle of those two numbers. So 15. Are my circles here? Oh, I missed a line. Are my circles here going to be open or closed? Closed circles because of those equal signs. And then an and compound inequality, are the arrows going to face this way, away from each other, or towards each other like this? They're going to face towards each other, and always faces towards each other. So shade it in the middle or make your arrows point at each other. Questions on that? Okay, Johnny's a shady guy, depending on who you ask. Johnny has at most $40 or a minimum of 85. Is this going to be an and inequality or an or inequality? Or. So I know for an or inequality, I only have one way to write this. I have to write them as two separate inequalities with the word or in between them. So it says Johnny could have at most $40. Let's say X is Johnny's money. I can't spell Johnny. Excuse me. How would I write that Johnny has at most $40? X is less than or equal to 40. I put the word or in the middle, or what? How do I say he has a minimum of 85? Read. Perfect. So that's my compound inequality for or. That's as much as I can do with it. So now let's graph it. I'm going to put the smaller number on the left, the bigger number on the right, and pick one number in the middle. Doesn't really matter. I'll go with 60. Open or closed circles here? Closed, because he could have $40 and he could have 85. We don't really know. Johnny's not the most straightforward kind of guy. Which way my arrow's pointing? They're going to point away from each other because or inequalities face away. Okay, any question on that? Can we do one more and then we'll move on to the next page? Ooh. It says you can go on your phone now for less than 10 minutes or later for at least 30 minutes. Is this going to be an and or an or problem? Or. We see that word or, right? That's what I'm looking for. I'm looking for ands and ors. So how do I say you can go on your phone now for less than 10 minutes? Let's call X the number of minutes. How do I say less than 10? Branson? Can we equal 10 at all? Not according to this problem. I put an or in the middle. How do I say at least 30 minutes? X is greater than or equal to 30. So I'm going to put 10. I'm going to put 30. I'm going to pick a number in the middle. Let's go with 20. Open or closed circles? Both. Which one's open? The 10 is going to be open. Ooh, the 30 is going to be closed. And that is totally fine. Which way does this point? Outwards, because it's an or problem. Any questions on that? Okay, move forward to the next page. Let's talk about the next topic here. Go away. So now we're actually going to solve them. It's not enough to just be able to write them and graph them. We got to solve them. But don't worry, the solving isn't too much different from what we were doing the last few lessons. So if I look at letter A, it says negative 2y plus 7 is less than 1, or 4y plus 3 is less than negative 5. Do we see how there's two inequalities there? All we have to do is solve each inequality separately. So it's basically the same thing, except, one problem we have twice the work in, but it's fine. So I'm going to split this down the middle. I'm going to take care of the inequality on the left first, and I'm going to solve this using my inverse order of operations. I'm going to subtract 7, and I'm going to divide by negative 2. What do I need to remember to do here? I got to remember I'm flipping my sign because I divided by a negative number. So that's that. I put my or in the middle, and then I solve the other side. That's literally all I'm doing. I just got to do it twice. So minus 3, 4y is less than negative 8. Divide both sides by 4. Y is less than negative 2. Any questions there? So this is like my solution. Now I'm going to go ahead and graph this. Remember to put your smallest number on the left. So what number goes on the left on my number line? The negative 2. Make sure that you're not getting confused because it's on the right side in the inequality. So I put the negative 2 down there. I put the 3 on the right. I'm going to pick some number in the middle. Let's go with 0. And then I'm going to graph it. Open or close circles here. What? Open. Which way does this point? Outwards, away from each other. Any questions on this? Ooh, can we load? There we go. Okay, can I show you one thing really fast? Because this is going to come up, and I just want to make sure that we're prepared for it. Let's say I do my problem. I solved pretty much everything correctly, except let's say I was bad. I forgot to flip my sign at the end. So I'm just doing a little hypothetical here. Let's say I have this. Y is less than 3 or y is less than negative 2. So the only thing that's going to change, if I think about it, y is less than 3, my arrow would point this way. We should never have a graph where the arrows are facing the same direction. If it is an and inequality, they'll face towards each other. If it's an or, they'll face away from each other. They should never both point the same direction. So if you get something that looks like this, then you forgot to flip a sign somewhere and you need to go back and check. Does that make sense? Okay, I just wanted to point that out so that we know in case we see it later on that that's what's going on. Okay, let's deal with an and. Same deal. When I look at this and, I'm going to split it down the middle, and I'm going to take care of these two inequalities separately from each other. First step on the left-hand side, subtract 2. And divide by 2 to get x is greater than or equal to negative 3. Am I going too fast? Are we okay there? I'm going to put the word and in the middle. And then I'm going to do the same thing on the right side. Subtract 2. 2x is less than 10. Divide by 2. X, let's write it down here. X is less than 5. So let's graph. I'm going to put my smaller number on the left, my larger number on the right. Can somebody pick a number in the middle? Perfect. Open or close circles here. Closed and open. Which one's closed? The one on the left is closed. Oops. The one on the right is open. Which way are we facing? Arrows point towards each other because I'm looking at an and problem, so I can shade in the middle. Any questions on that? Okay, now I'm going to show you something a little bit weird. Look at C. This is an and or an or problem here. How do you know it's and? Because the signs are the same. I mean, technically, we could argue that, but how do I know that this is an and problem? Super simply, Jaden. Yeah. Remember, or problems always have the word or in them. Okay, so if you don't see the word or like this, it's going to be an and problem. Now, there's two ways that and problems can be written. We just did one way. So I could take this and problem and I could split it to make it look like this guy up here. Can we do that really fast? Let's write this as an and problem that is expanded. So let's say negative 2 is less than 3y minus 4. Put the and in the middle. 3y minus 4 is less than 14. So I split that into two separate inequalities. Just like we did in the last problem, I can solve these two inequalities separately. Let's go ahead and do that real fast. So, did I lose you? You see how this part is shared? So I have one inequality here, and I have one inequality right here. So there's two different pieces here and here. I know it would be faster if we solved it all at once, but I'm going to show you how to do it this way first. So I can add 4 to both sides. I can divide by 3 to get 2/3 is less than y. And plus 4, 3y is less than 18. Divide by 3, y, let's put it down here. Y is less than 6. That's one way. But let's say, like Brayden said, that takes a long time. I'm doing 2 problems all the time. I don't want to do 2 problems every single time. So here's what we can do instead of splitting it up and doing it side by side. Is I can take a look at this. And you know how when we solve equations, we always do to one side what we do to the other? Right? We have 2 sides of the equal sign. Well, we're going to do the same exact thing, except this time I have 3 sides. I'm still trying to solve for y to get y by itself. So I'm going to do inverse order of operations. But anything I do in the middle, I have to do on the left side and on the right side as well. So what would be my first step for solving for y here? Plus 4. I'm going to do that on the right side and on the left side. So I get 2 is less than 3y is less than 18. Then what would my next step be? Divide by 3 on the left side, the middle, and the right side. So that leaves me with 2/3 is less than y is less than 6. So that says the same exact thing that it does over here, just maybe using a few fewer steps, right? As long as we remember to do the same thing on the left, middle, and right. So let's do this. 2/3, 6. Can we pick a number in the middle somewhere? Sure. Open or close circles? Which way does it point? Towards each other. It's an and problem. All right. Any questions on that? Yeah, we can be done.